So let's go ahead and jump in. I'll say good morning or good afternoon, depending on where you are. First, I'd like to welcome everyone to the first ever Pulsar Summit, Messaging and Streaming Everywhere. I'd really like to thank everyone for joining us today. We have 2 days of amazing content and speaker sessions planned. My name is Carolyn King, and I'm going to kick off the event today with some exciting news and updates. And then I'll be handing it over to our Apache Pulsar PMC members, Sijie Guo and Matteo Murley, for our keynote this morning. So first, we'd like to thank everyone who's put so much time and effort into making this event happen, beginning with our event hosts, Stream Native and Splunk. We'd also like to give a big thanks. There we go. We'd also like to give a big thanks to our event sponsors. Our platinum sponsors include TIBCO and Yahoo Japan. Our gold sponsors include JustPay, Verizon Media, Iterable, and MemSQL. Our community partner, Flink Forward, and our publishing partner, Manning. This event wouldn't be what it is without all of your support, so thank you. Next, we'd like to give a big thanks to our program committee. They reviewed all of the submissions for this summit and really helped to ensure that the next 2 days are filled with interesting and educational sessions for everyone. The committee includes Sijie, Matteo, Zhao, Jesse, Nozomi, Jerry, Ben, Dave, and Yuva. Thank each of you for all of the time and effort that you've put into this. And last but not least, we would like to thank all of the speakers who've put in time and effort to join us today. They each bring deep industry experience and expertise and have amazing sessions planned for all of you. There are too many to mention, but I would encourage you to spend some time learning more about each of our speakers and connecting with them as well. We'd also like to encourage you to reach out to all of our sponsors, program committee members, speakers to connect with both during and after the conference. You can find out contact information on the Pulsar Summit webpage, or you can reach out to us on our Pulsar Summit Slack channel. Okay, great. So with that, I would like to take just a couple minutes and talk about the Apache Pulsar community in 2020. So I know for many of you joining us today, this may be one of your first experiences with Apache Pulsar and the Pulsar community. You will soon find out that this is a really active and highly engaged group. 2020 has been a particularly big year for community contributions and participation. Some exciting programs that launched this year include TGIP, which is a weekly Pulsar training that's live streamed on YouTube every Friday, as well as monthly webinars with some of our community partners. 2020 has been a pivotal year for the community, and we're excited to see what happens as we continue into 2021. So in addition to more trainings and webinars, we've also seen a number of great contributions from across the Pulsar community. OVH Cloud and Stream Native launched KOP, or Kafka on Pulsar, earlier this year, and China Mobile and Stream Native recently launched AMQP, which Matteo will talk about in more detail a little bit later today. If you're interested to learn more about Pulsar and find out more about trainings, case studies, etc., there are a ton of resources available to you. And that brings us to our biggest community event of the year, the Pulsar Summit Virtual Conference 2020. This is the first global meeting of the Apache Pulsar community, and we're thrilled with summit signups and engagement, as it really illustrates the depth, strength, and continued growth of the Pulsar community. In the next 2 days, we'll hear from 36 speakers review more than 35 sessions. We have over 550 attendees signed up, representing more than 300 companies globally. So definitely a really exciting event for Apache Pulsar and for everyone attending today. So with that, we'd like to encourage you to get involved. There are a number of different ways to get involved with the community. First, join our Slack channel, apache-pulsar.slack.com. We have a special channel set up just for the Pulsar Summit, which will enable you to connect with fellow attendees in real time. We also have a job board channel where you can post and search Pulsar-related jobs. We have the Pulsar Summit newsletter list. If you're not signed up already, this is a great place to learn about upcoming webinars, product releases, case studies, and more. You can follow Apache Pulsar on Twitter. And finally, a great way to engage, at the end of the summit, we'll be sending out a post-summit survey. We really encourage you to take that as well. Great. So with that, we'll just go through a couple conference logistics and then we'll jump in. So as you can imagine, we had a short period of time to transform the Pulsar Summit from a planned in-person event in San Francisco to a digital event. While we anticipate this event will run smoothly, we definitely appreciate your patience with any issues or road bumps along the way as we navigate these new digital event waters. So with that, just an overview of how the event's set up. We're going to begin each day with keynotes. The keynotes will be in track 1. At the conclusion of the keynotes, we will have breakout sessions available across 3 different tracks. We'll have a separate Zoom link for each track. So if you start the day in track 1 with a keynote and later want to move to track 2, simply log out of that Zoom meeting. You can find the Zoom meeting for track 2 on the Pulsar Summit website, and it's very easy to join session by session. For a full list of the schedule for the next 2 days, you can look at the Pulsar Summit website. And finally, Pulsar Summit track moderators. Again, my name's Carolyn King. I'm the head of marketing at Stream Native. I will be your moderator for track 1. We have June Wang, our marketing and events manager, moderating track 2. And finally, we have Rosalie Bartlett, senior community manager from Verizon Media, joining us for this conference, and she will be our moderator for track 3. You can contact us with any questions at events@streamnative.io. Great. So with that, I'm going to go ahead and hand it over to Matteo and Sijie.
Matteo, hi, and I'm a senior principal engineer at Splunk, and I'm the co-creator of Apache Pulsar. I'm a PMC chair. I'm also one of the ex-co-founder of Streamio.
And thanks, Matteo, and good morning and good afternoon, everyone, depending where are you. So my name is Sijie Guo, and I'm currently one of the co-founders of Stream Native. And I'm also the PMC member for both Pulsar and Bookkeeper project. I worked with Matteo before as one of the co-founders of Streamio, and now Streamio was acquired by Splunk, and this conference is co-hosted by both Splunk and Stream Native, and I would like to hand over to Matteo so he can talk about one of the co-hosts, Splunk.
Sure. So for Splunk, really the mission is to help enterprise to make sense of data and analyze it in real time and monitor and reports like all kind of data. So from Streamio, we've been acquired from Splunk in late last year, and as part of Splunk investing more and more into the streaming data space. And today, we have been introducing Pulsar in multiple product lines, so Splunk itself is now deeply committed to Pulsar and developing the Pulsar project and the community around it.
Thanks, Matteo. And as one of the co-hosts, Stream Native is founded by a group of developers of Pulsar and Bookkeeper. Most of us are contributors to these 2 projects. Our goal is to enable companies to access enterprise data as real-time event streams. So we contribute and help a lot on growing the communities of both projects. have helped people adopt Pulsar to address their business problems. Besides that, we also provide managed Pulsar services and enterprise support. So to kick off the keynote session, I would like to start with sharing a few stories of how people are using Pulsar today and what is driving the Pulsar adoption. And after that, Matteo will talk about the roadmap and the future of Pulsar. A lot of people ask me what is Pulsar. So Pulsar is a cloud-native messaging and event streaming platform. Now, let's look at how companies globally are leveraging Pulsar's messaging and event streaming capability. Let's start with Splunk again. Recently, Splunk announced its data stream processor, which is based on Apache Pulsar. I'll hand over this to Matteo, and he can give an overview about Splunk's adoption story.
Hey, thanks, Sijie. So in Splunk, like we've been there for like a few months now, but really we've been able to get up and running very quickly and integrate Pulsar into major product lines, as I say. So the biggest and best example is a Splunk DSP, data stream processor product, which has been migrated over to Pulsar, has the backbone of the data ingestion and storage of the inside data. As part of the same effort, we've been using the Pulsar connectors, and we've also been extending these as with batch connector as well to provide a very flexible ingestion platform into Pulsar. And finally, we also have a Pulsar service for Splunk products that is basically like on-demand managed service.
Thanks, Matteo, and it's very excited about Splunk's adoption story. And now let's looking into retail industry. Nava, one of the fast-growing companies in retail industry, it has adopted Pulsar for about 1.5 years. They use Pulsar for real-time transactional messaging, data integration with data lake, and event processing. Pulsar is used in the core business, and it's super mission critical. Now they are using Pulsar for processing 50,000 of transactions every second. It's a very large scale. Just remember it's transaction. In education industry, Instructure has adopted Pulsar for more than a year. It has been running 8 AWS regions for powering its core Canvas product. The busiest region is processing 50,000 messages per second. They choose Pulsar for unified messaging model and easy to manage long-term retention with very low cost. Now let's look into a different industry, cloud computing. Clever Cloud, one of the largest PaaS provider in Europe, has adopted Pulsar for its log ingestion pipeline and function as a service for more than a year. They choose Pulsar for its multi-tenancy, proxy architecture, and built-in integration with S3 and Presto. Just remember multi-tenancy because you are going to hear I mention multi-tenancy many times. We have talked about a few examples in the Americas, in Europe. Let's take a look at a few more case studies in Asia Pacific. Tencent, one of the largest internet companies in Asia, has adopted Pulsar for more than 2 years. For people who don't know about Tencent, it's the WeChat company, and WeChat. They adopt Pulsar for financial use cases and log pipelines. Pulsar is used for powering Tencent's billing platform, and it processes tens of billions of financial transactions every day. So essentially, every purchase you made in Tencent product lines will be processed by Pulsar. So besides the whole billing platform, there are more and more departments within Tencent start using Pulsar to replace other messaging solutions like Kafka. Now, let's take a look at a different industry, like live streaming. Huya Live, one of the largest live streaming service provider in China in Southeast Asia, use Pulsar for its log pipelines to process 15 million messages per second. So they choose Pulsar to replace its existing Kafka infrastructure in favor of Pulsar's instant scalability in multi-tenancy. Not sure if you heard about Yum China, but I'm pretty sure you know about Taco Bell, Pizza Hut, and KFC. Yum China is China's largest restaurant company with 8 billion revenue back in 2018, last time I checked. It adopted Pulsar for its notification and order processing system. They chose Pulsar for its instant scalability and multi-tenancy. It was used for replacing its existing RabbitMQ infrastructure. So here we see a broader snapshot of companies that have adopted Pulsar globally. And of course, there are many more not featured here. We have just looked at a number of case studies from retail to cloud computing to live streaming, and have had the opportunity to see how different companies have adopted Pulsar. Some of the companies are also presenting in this conference. For more details, please check out the website and check out their sessions. So in the next section, we are going to look into what is driving Pulsar adoption. So in order to understand what is driving Pulsar adoption, the PMC ran a Pulsar user survey end of last year. We have collected some useful insights to help the community understand what is driving the Pulsar adoption. So people choose Pulsar because Pulsar is able to increase the agility of business development. It helps unlock new use cases for the business. It reduces the cost as well as improving the customer experience. People came to Pulsar for many reasons. The top 3 reasons that people choose Pulsar is the architecture design and all the benefits associated with it, such as scalability, availability, and resiliency. And in our previous slides, we mentioned a few the case studies, and it shows that people use Pulsar for many different type of use cases. And the top 3 use cases that we survey in the user report is building asynchronous applications for microservice, building the core business applications such as billing, transaction processing, order processing, payment processing, and collect log data, event data, sensor data for building the data pipeline. So Pulsar is commonly known as a pub/sub messaging system, but besides Pulsar being used as a pub/sub messaging system, people also adopt Pulsar to use its many different features. The most commonly used features are like multi-tenancy, functions for event processing, tier storage for offloading the event data for long-term storage, connectors for ingesting data in and out of Pulsar without writing any code. And another interesting takeaway from this survey, as you can see, that a lot of people adopting Pulsar for upgrading their existing messaging infrastructure. But from the survey, we also noticed that close to 42% of people consider using Pulsar to replace 2 or more messaging systems. It's just because Pulsar is a unified messaging and event streaming platform. And so there are many different ways to mention the growth of the Pulsar community. In 2018, Pulsar became the top level project. Since then, the adoption has grown rapidly. For example, I just listing one of the key metrics that we show here. The number of the Pulsar contributors has increased 7 times in the past 18 months, from about 40 contributors to 280 contributors as of today. So it grows a lot, and it happens everywhere in the world. Now back to the original question I raised earlier in my session, what is Pulsar? So the community already has answered for that. It's a cloud-native messaging and event streaming platform. It provides the capability to produce and consume event streams store infinity event streams, and process them. Now, people will wonder what would be the next for Pulsar, and I'm handing over this to Matteo. He will share more details for the development and the roadmap of Pulsar.
Thank you, Sijie. So we're talking about what the future for Pulsar is, what waits for us down the road. But before doing that, let's take a step back and look at the history of Pulsar. So we started Pulsar at Yahoo in 2012. So the mandate we had from the company was to create a scalable multi-tenant messaging service, and we went through a couple of iterations in there to get it right, and went to production with this different version of Pulsar, and then eventually in 2016 we were ready to open source that, and that was I think a very good decision by Yahoo, but we didn't want to have this as a Yahoo open source project, but rather we wanted to be more inclusive of other companies and to get other perspectives into the project, and to get people to adopt it and contribute it, not just look at it. So we went to the Apache Software Foundation in 2017 as with an incubator program. And in 2018, we were able to show that the community was maturing enough that we were promoted to top-level project, and we hit another big milestone that was Apache Pulsar 2.0 that was released in 2018. With that set the stage for an increase in adoption, and that's what you saw in the previous slide from Sijie, and that happened like last year and this year. And so if you look at today, we had this huge growth for the project. We had this that happens in multiple areas. So one is community, as you've seen, multiple contributors, multiple users of Pulsar that also have went into the scope of the project that is vastly bigger than what it was at the beginning. And the features. So we've been adding a lot of features. We've been adding a lot of new functionalities on the project. But the cool thing, I believe, that is that we were able to do that without changing the nature of Pulsar. Basically, like we had this core of the system, and we built on top of it. We didn't have to like re-platform that, and we knew what the strengths of our architecture was and we were able to add on top of it. So the path that we've been following was always the same. We wanted to focus on providing the best infrastructure for messaging and event streaming, and building on what our key differentiators, and finally, like listen attentively to the users, because we need to solve users' problem and not just making things for the fun of it. So if we make the users' life easier, that's where we get this feedback, and we can like build like very useful products. I talk about the evolution. So we started with PubSub, right? So and that was like the first interface that we wanted that we needed to expose, and the PubSub was implemented over distributed log storage. That means that we had like a really a solid storage layer that also is scalable, consistent, durable, and very solid. On top of that, we built this PubSub, very flexible PubSub API. The natural evolution of that we've been working on in the past year was to add schema to have the structure for this data that is being stored. And again, listening to user, we figured out that people wanted to do very simple processing on top of on these topics, and therefore we introduced Pulsar function to have these no API serverless like approach to computing. And from function, we take the leap to Pulsar.io, which is connector framework, so that you don't have to write any code to ingest from common data sources and things. And we also add the Pulsar SQL, which is the REST integration to have like interactive queries. And finally, the tier storage, which is more like a system level feature, but it enables to have this infinite stream capacity. So the question now is, where do we go from here? So this is what our path in the past. So what lies ahead? So you can break it down for different areas. So Pulsar is a really composed of these 3 different areas, which is messaging, compute, and storage. So on the messages end, the goal has been and always is to allow any application to easily produce data and consume data from Pulsar. So that is the interaction layer. So we need to make it so that if from each language you are able to publish data and consume data, and from anywhere and with different protocols. So there have been different efforts on that in the past, like adding new client libraries and in different forms. There is also new efforts building a different approach, which is the protocol handler. So basically, like instead, there are applications that are already built with different APIs or different protocols, and we basically can expose those in the Pulsar broker. So the Pulsar broker can speak the native protocol, but can also speak different protocols, like for example, Kafka or MQP or MQTT. So this basically like will allow application to just switch their endpoint to Pulsar brokers and without changing any code or changing any dependency libraries. And we've been like planning for multiple features. So there's been transaction work that has been going on for a while. There's been a lot of progress already, and it is expected to come up in the very next release, which is 2.7. 2.6 is really almost out. So this is almost done. We have been thinking about adding a REST API. That's kind of like to have the simplest possible way to produce and consume without any kind of like client libraries. You just use whatever HTTP client you have, and you're ready to go. So that even if your language doesn't have a binding like client library for Pulsar, you can still publish and consume data. There is also work on read-only brokers. What that means is that you can have brokers that can read from topics without being owners of the topic. So that means you can scale out the consumption, the fan out. So if you have like hundreds of subscription on a single broker, you can have some of this subscription to be handled by different brokers. So there is no like a single bottleneck there. And also you can scale up the brokers on demand. So it is much more lightweight if you don't have to take over the topical ownership. Another new feature that we are working on is a script producer. This is more like also like exposing the full power of Bookkeeper that is handled to Pulsar user. So the fencing mechanism in Bookkeeper is very powerful, and providing a single writer enables to have like a very precise fencing at the storage level, and also like application can use that to have a leader election kind of mechanism, so that they don't have to use another system to do the leader election. They can just use a Pulsar topic and the Pulsar producer for doing that. And this is another big ticket item, and that's something that we've been thinking on and off for a lot of time, and I think that's kind of like that's the right time and right place to do it. Is partition autoscaling. If you look at partitions, the partition basically are an artifact of scaling. So you use partition not because you like partition, you use partition because you want to spread the load across multiple nodes. But this introduces complexity to the applications, and this complexity should be really hidden, because applications really don't care about partition. They just care about, I want to have a topic and I want to have hugely scalable topics. I don't want to care about how it is done. So the point here is that Pulsar should be able to automatically manage those partitions and increase and decrease the number of partitions based on the load, all at the same time with retaining ordering. So right now you can increase partitions, but it is disruptive of the ordering. So because the way that messages are routed to partitions. And finally, this is also about removing a long-standing duality between partition versus no partition topic, which is kind of like confusing to Pulsar newcomers. this differentiator, and so that we kind of like solve all of this. And finally, on the messaging side, we've been also started doing the work to basically use a pluggable metadata store. So we use right now Zookeeper, and as most of you know, as for metadata store and coordination service. But we want to abstract those through a pluggable implementation, so that we can be using different implementation as the user need or like. And in the future, we also want to basically have these as an out-of-box support within Pulsar, so that we don't have to depend on external system. And going forward to the storage. The storage, again, there's no like change in direction here. So the line here has always been to push the boundaries to build the best scalable stream storage, and that means to have great performance and operability tools at all levels, and to have a low cost in the storage, because storage is typically like a large part of the cost in a big deployment. So we need to be able to use the storage very efficiently. And there's been a lot of behind the scene work that has been happening, and it keeps happening to ensure that we can perform very well in every environment. So, and there are widely different environment and that Pulsar is being deployed, and in the cloud environments with multi-cloud, and each cloud provider has very different settings and very different devices for disk and so on. So we are optimizing for many of them, and also for on-prem. So it's kind of like different angles there on making sure that Pulsar plus Bookkeeper is able to perform well everywhere. And also, like we've been tackling different requirements. So some applications are like favoring a very strong consistency and durability. That was like always the Pulsar main point here. There are also like different applications that really want to have like a very low cost and huge throughput. So we can tune and support at it in a very effective way both of them. If you look at how the storage evolved itself, we have we started with the distributed log storage, and we added the schema, as we said, and then we realized that we can use the tier storage to take advantage of cloud storage, which is much cheaper than having VMs. So we basically we can have this infinite stream. After that, we added topic compassion, and so that we can have the stream and the table at the same in the same topic. And we also added the key value, so that function can use counters and can use a key value access for that state. So the next evolution. So if you say we have tier storage, that means that we can store a huge amount of data into S3, for example. And right now we can only basically like read this data. This data is stored in segments, but these segments are stored as they were in the topic. But if you want to do like run analytic queries, for example, like with Spark or with Presto in Pulsar SQL, we need to have some kind of indexing and some kind of columnar access. So the idea here is that we want to be able to, when we offload, we can offload, but transforming the data from your current schema, say that you declare your schema on the topic. Basically, we can transform this data into Parquet or ORC files, so that an analytic framework can just read the data from S3, and it is ready in that columnar format that with indexes and everything that will make basically the querying of the data in topic very efficient. Another area that we are working actively on is on the state store. As I said, that the state store is is a key value store that is right now it is used by Pulsar function. We plan to use it for multiple usages as well inside Pulsar, but we want to mature the state of the global state, and basically like the main area here are to add hot replicas to have super fast failovers. Right now we have to recover a bit, so it can take some hundreds of millis to recover that. So we want to have basically like less than 10 milliseconds failover in case of failures to replicas. And then we need to add extensive monitor and testing on the global state, so that it is like really rock solid. Another feature that I believe it is very important for a state store is to add the change data capture. That will basically enable us to have these notifications, and that will basically allow to do local caching at the client level. So in this case, the function will be able to basically serve all the read traffic through this cache that is basically fed by the change data capture. And with this, we can basically support like very read intensive data accesses that right now will be going through an RPC to the state store service. And finally, the processing. So we've been basically supporting, and will be always be like a different kind of processing layers for what makes more sense for the job, right? So we have the built-in processing path, but we also integrate with the existing platform. And in the specific, right, we've been adding Pulsar function as a way to do very lightweight serverless compute. If you don't have any very complicated requirements for your processing, Pulsar function probably is a very good choice. But like for more heavyweight batch system processing, Flink and Spark are supported, and like first class citizens here, and also like Pulsar SQL. So we support Presto and for interactive queries. And on the Pulsar Flink side, there's been work to push that Pulsar Flink into the mainline Flink, and also to have like integrated with the proper Flink as for like batch and stream duality, so that we can have the best possible way in when Flink is doing like batch processing or when Flink is doing stream processing, and also like bypassing the brokers when doing this batch level access. And eventually, the idea is to generalize all this work that is being doing that is being done for Flink and was done for Presto into a general use API. So basically, like give users a way to take advantage of the work that has been done and for other uses. But basically, like having one more layer to access the data, so you can have like an official supported API that can allow you to access data directly from Bookkeeper and tier storage, bypassing Pulsar brokers, for example, so that you don't like disturb the real-time workloads. And this API will be integrated into Pulsar Flink, Pulsar Spark, and Presto. On the function side, one item of work here is have multiple languages, pluggable languages. So we support multiple few languages now. We support Java, Go, and Python, but adding a new language is not very easy. So it has to be touched in the course. We want to basically abstract that part so that it will be very easy for users to add new language runtimes. And the function registry is to really just enabling users to share functions without like keep submitting the same code over again. And on the operational side, the versioning was a very a long time asked feature that we basically want to be able to precisely control and know what version of a function it is running, and be able to roll back. Say that if you deploy a new change in your function, you submitted the new code, and you find out that there was a bug in that function, you want to roll back to a stable point, so that upgrades roll back and A/B testing and everything. So that kind of like improving the operability of functions. And we've been working on batch connectors as well. I say that as part of Splunk, but there's going to be more connectors as well, and down the road on both batch and stream. And one of the newest proposal is a function mesh. So if you take a look at the function mesh, is basically like building on top of what a single function can do and compose them. So you can use a YAML config or a simple DSL to declare your topology, basically, and declare what kind of sources and sinks and functioning in between. So you can stitch them together very easily. So you can have a source that passes on to a function that passes on to a sink. And so this is kind of like a simple case, but you can also generalize into a more like complex DAG, so that you can have multiple functions and build a really complex processing pipeline. And finally, the management tools. There's been lots of improvements there, and there's still a work going on the Pulsar manager to support schema, and this also expose functions and connectors in the web UI, and also integrate with the Bookkeeper Visual Manager, so that we can also manage Bookkeeper nodes and monitor them from within the Pulsar manager. There's a Pulsar control to have a Go-based CLI admin tool. Everyone that uses the Pulsar admin Java client will be thankful for this for the startup time. There is a help chart that is officially supported by the project now for Kubernetes, and there is also work. I think that multiple people working on Kubernetes operators, and hopefully we can have one that is open sourced very soon to easily to make like all the complex operational decision like embedded in the operator itself. And on the policy side, we have right now only namespace policies, which is kind of like limiting sometimes. So we need to generalize these into exposing like a through hierarchy of policies for tenants and namespaces and topics, so that is kind of like more full-fledged. And interceptors. So this is more like having tracing and extending broker capabilities, so that you can plug your own interceptor and know and basically get called when broker is doing some operation, and you can change the outcome of these operations as well. And last but not least, the system topics. Basically, like many people ask always to have the notifications when something happens on the system. For example, like topic is created, you want to get a message on one system topics, or namespace get created, or any kind of system events. You want to be able to consume that and act on it. And with it, I'm done with the future talks, and I will give the word back to Carolyn. Thank you.
Great, thank you so much, Matteo.